No. Anybody else?
Wait, is this the thing that we're supposed to do? Like, what's that thing, like?
So could it be like something about like if something costs that like is higher than $1? Or could it not count for that?
Percentage or something has changed.
Really?
Whoa.
Going out on a limb there, huh? Okay. But what does that mean? Or what circumstance would you talk about a percentage change?
Like a different price?
Like, the average of it?
Not the average.
I don't know.
You
Like,
had so much of something, but then you don't, so you wanna find percent of how much you lost.
Okay. I can live with that one. That's a pretty good example. What do you got?
like if something costs $14 and you give them 20, the percent of that number that you get back.
So this would be like, okay, so here's another question. Could I have a positive percent of change? Could I have a negative percent of change?
Yes.
I can have both? Okay, is if I have a positive or a negative, if you think there is both, is a positive percent of change necessarily a good thing?
No.
Or a negative necessarily a bad thing? No? Okay. So other examples of what you think this could mean. In a sense, you're all on the right track. Caleb's probably the closest. Addie just said the words up there in a different order, kind of, to make her try to sound smart. Okay. So the percent of change might be if our business grew, right? How much by us in the last year building more restaurants? How much percent of change did we have with the amount of buildings we have now? Maybe it's more about price increase to decrease with going through COVID. Okay, if you own a business, the percent of decrease or increase, again, might be a positive thing, might be a negative thing, but did we increase our value? Right? Did we increase the production that we had? Or did, because of this, going through this cycle of, the virus and maybe having to close down, I don't think you guys realize how much everybody else in the nation is still struggling with this. Because where we live, we're pretty normal. Besides wearing the mask, right? But I mean, there's a lot of stuff open and we can go to things. Do you realize kids in New York haven't gone to school yet? Right? Okay, so you can't even go outside, in certain places in the United States. So obviously their percent of decrease would be phenomenal if you owned a business there, because your restaurant's probably closed down now, and so on and so forth.
And that's why I'm moving.
Where are they gonna go?
They're coming here because there's more workers available here than there is in like bigger cities.
We're so lucky.
We don't want more people, because then that's gonna happen to us.
And that's gonna
But
happen to
yeah,
We don't
us.
want too many.
But we're still like really spaced out.
Really spaced out, okay. Yeah, kinda. Compared to New York, yeah. Okay. Alright, so everything that we talked about is kinda right. Alright, we can have a percent of increase. Or a percent of decrease. When you have a percent of decrease, make sure that you show it with a negative sign. Alright, percent of increase. A lot of times in the book, they'll even show it with a plus sign, but you don't necessarily have to, because when we know that, or when we see a number that doesn't have any sign, we know that it's a positive number anyway. Alright. So there's a couple different ways that I can do this. We're still going to go back to our good old reliable proportion of thinking about the part over the whole. And what was my other ratio?
It's over.
Well, that's the same thing as part over the whole, right?
Percent over 100.
It's always got to be the percent over the 100, right? So again, because we're finding the percent of change, a lot of times we're going to find this percentage. Okay, so realistically, there's two different ways that I can do these problems. Number one way is doing this right here. Okay? If you're going to try to do this proportion again, you always want to make sure that the part is, in our case, the amount of change. So they're going to give you two numbers and they're going to ask you what is the percentage of change between those. The first thing you're going to do is take those two numbers and subtract them. And that's always going to be the part, or the top part. Okay? Now, if you want to do this consistently, I would always do the new number minus the old number. So they're going to say it went from 14 to 38. Well, my new number would be 38. My old number is where I started from. Okay? So this could be from, and this could be 2 if you want to think of it that way. Okay? Now, realize though, if I'm going to do this every single time, the new minus the old, when would I show a decrease? If the new number was what compared to the old number?
Bigger.
Smaller, right? The new number is less than the old number. When I do my subtraction, I'm going to get a negative number. So then when I put it into my proportion, my negative number is going to be over the whole. And then this percentage would end up being a negative percentage, so that would show me a percent of decrease. Okay? So again now, the part is always the amount of change. The whole is always which one? Is it what I started with? Is it what I ended up with? Yeah, so this is the original amount. So if you like that, maybe you come up here, it's from, or it's your original amount. So you can write that down here. This is the from part. And again, when I say it's the from part, they're going to give you a sentence like they did with the other sentences. You know, remember the is over the of sentences where they had is and of in that? They're going to do that same thing, but they're going to say from some number to another number. That's what the from part means. And that's always going to be on the bottom. Okay? So, you could do this. The second way that you can do these kind of problems is basically you're going to make your first ratio again, like over here. So you're still going to do the part over the whole. And essentially, what do I really do to that number right there? Well, I'm going to divide that number. Or I'm going to take this number times 100 and then divide, right? To get my percentage. So another way of doing this is I'm going to divide by 100. So I'm going to make my first ratio. And then I'm just going to move the decimal place. Two places. And why is it two places again? Because we're basing everything off 100. And if I'm going to move my decimal, which way am I going to move it? To the left. So essentially, these two things are exactly the same. If this portion right here, or what I'm trying to explain right here, confuses you, just set it up into the proportion. You're essentially doing this, you just don't really realize that you're doing it when you're doing your proportion. That makes sense what I'm saying? So some of you that your minds are way ahead, or going faster, that might make a little bit more
Smart,
sense.
smart individuals like me. Oh.
That ain't gonna make a comment.
Hello.
Alright. So, does this make sense? So let's try it out. Here's my sentence. So we're going from 325 to 390. So again, the from, this is my original number, right? So if I looked at this problem right here, just by the sentence, is it a positive or a negative percent of change? Positive, we went up, we got more of something, okay? Either our production went up or the amount of money we went up or something. So again, we're always, again, you want to do the proportion, we'll do it both ways in this case. We'll show you how simple this is if you have a calculator, okay? What's going to go on my denominator of my first ratio? Always the original amount. So again, don't just think, hey, I'm going to always put the bigger number there. Okay? Now, what goes on top?
390.
It's the amount of change, right? So when I do the amount of change, what's that tell you? I got to subtract them. And I'm going to do the new number minus the old. So I'm going to take 390 minus 325. So we get 65. That's the amount of change. How much difference was there between the two numbers? Now it's a positive 65, so it's going to tell me it's a percent of increase, right? So now we're ready to do our math, right? 65 times 100 would give me 6,500. And then I'm going to take that and divide it by 325. 20%. So it's 20% what? Increase, right? Now, the last thing is, does that make sense? From 325 to 390, if we go up by 65, would you basically say that's up 20%? Yeah, at least it went up, right?
Wait. How?
Now, somebody take 65 and put 65 divided by 325 in your calculator. So we get 0.2. So, do we want to come back and change this up here? If it was 0.2, but we wanted it as a percent, where should we move our decimal? To the right. So let's go back up here and change it. I'm going to move it to the right. But essentially, we get the exact same thing, right? So if you want to just set up this ratio, and again, the ratio is the most important part of it. The amount of change over the original number, we get that decimal and we move it 2 places to the right. So essentially, you're just ignoring this other ratio, but you're really doing it. Okay. So let's try another. From 50 to 67. So again, increase or decrease? Increase, right? From where we started to where we ended up, we got more. So anytime it's more, it's an increase. So again, what goes on the bottom? We always put the original amount. Where did we start from? Okay? And then what goes on top? 17, the amount of change. So basically, we're going to take 1,700 divided by 50. Right?
34.
So we get 34%.
Yep.
So is 17 basically a third of 50? Right? Over here is 65, basically 20% of 325. That one's maybe not as easy for you to see, but it still works.
It's exactly 20%.
Why do you then turn it to 100? Why can't you just take 17 divided by 50?
You can.
what's the point of adding 100?
So you're continually using a proportion if you don't understand that part. It's just two ways of doing it. You just gotta make sure you move your decimal 2 places to the right.
It's not like,
What?
on like the second way to do it.
The second way of doing it, you just punch this into your calculator right here. 17 divided by 50. And then take that answer and move it 2 places to the right. So you should have gotten 0.34. Then I move it 2 places to the right, so I get 34%. Okay? Exact same way, it's just 2 different ways of doing it. All right? So, then let's do this. From 80 to 55. And they put centimeters, but that doesn't really matter. So again, increase or decrease? Now we're going to have a decrease, right? So this is where, especially when I do a problem like this, and if you don't want to do the proportion, that's all right. But I still want to make sure that this ratio is right. So what goes on the bottom? Still the original number. But again, I'm going to do 55 minus 80. So I get negative what? Negative 25. And this just shows me that when I have a negative up here, I know that I have a negative percent at the end. And if I have a negative percent, then it is a decrease. Okay? So, again, I either do negative 25 times 100 divided by 80, or I just punch this into my calculator and I get what?
Negative 31.25.
31.5? There's probably a negative symbol right down there. So punch in your, you gotta punch in your number first and then punch the negative.
Or I have to do this where you have to.
What?
0.25.
I have to press up.
So again, make sure that you read the directions to see if they want you to round it to something. Okay? So just make sure of that. Again, tenths, hundreds, thousands, and thousands. Okay? Questions here? Is that okay? Don't need to do any more of those kind. So again, the biggest thing is that you have to do the subtraction. That's where a lot of people mess this up. They start going really fast and they don't do the subtraction. All right? Next one up here. Story problems. We love story problems, right? Yep. Yes, Carson, we love them. When John went to college, tuition was $7,500. When his daughter went to college, it was $25,500. Right? So, believe it or not, this is you guys going to college compared to maybe even mom and dad. But definitely grandpa and grandma. Okay? So, find the percent of change. So here's where you got to think for a second. Stop and think for a second. So again, I'm going to always show myself, especially in this, I'm going to show my proportion, even though I might not necessarily use my proportion. Okay? Where did I start from? 7,500. Okay? Because that was the first graduate or college tuition. How much change did I have? $18,000. Again, remember, the new number minus the old number. Nope, because the new number is bigger, right? My new number is 25,000, so it's the bigger one. So we're going to have 18,000. So realistically, before you even do the math, what kind of number or what kind of percent should I get for this problem? A ginormous one, over 100, right? So, 18,000 times 100 divided by 7,500. Hey, do you all realize that I can just cancel out all the zeros if I wanted to? Yes. Okay? So, if you don't have a calculator, instead of doing all that work, I'm going to do 180 divided by 75, essentially. Okay? So, how much do I have?
240%.
So, did it more than double? So think about it. If I take 7,500 and double it, I'd have only what? 15,000, right? 15,000? But then it still went even more than that. So does it make sense that it's 240%? So from when grandpa and grandma went to, or possibly even mom and dad went to college, to when you're gonna go to college, the price of college went up 240%.
Pretty sure it's higher than that.
You think it's even more than that?
Yeah, and by the time when we get there, it's gonna be even higher.
You think?
Yeah.
Potentially, yes.
Because,
Especially after this year, right? You realize that how much college tuition's probably gonna go up everywhere because they gotta make up for this year. You know what I mean? Okay, well, hopefully not, right?
no,
Are we okay with that? You wanna do another story problem?
no, yes.
Yes.
So we-
In 2000, there were 356 endangered species in the U.S. In 2000, or a year later, there's 367. In 2019, there's going to be another one. The amount of colbecs that are endangered.
What does that mean?
Take it however you want. So, here again. I'm going to do this. Again, you don't necessarily have to do this. Where did we start from?
356.
356 we started from. New minus the old. So, new minus the old gives me what? How much? How much?
11.
New minus the old.
Negative
11.
11.
Right? The old is my original.
Oh, wait.
You're right. 11 divided by 356. Or 11 times 100 divided by 356.
3.08988764. Boom.
We'll say
Even.
09.
No, actually, no. That's
Now, does that make sense? When my top number is really, really far away from my big or bottom number, we should have a really, 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 really small percentage.
30.
And again, you notice it only went up 11. Right?
Oh,
That's still, yeah, really bad. And now we got another species that is close.
oh, you forgot the 8, so it should be 3.1. There's an 8 in front of the 9. Oh, wait, no, in front. Actually, it could still be 3.1 because it's 9.
Could be. Depending on what they ask, right? I'm actually on his side.
No way.
Yeah.
No way.
All right, questions? Does this make sense, what we're talking about here? Everybody? Again, this is stuff that you might not have seen a whole lot of from here on out, so make sure if you got questions, you come in and see me. Or you ask Ms. Christoffel.